Now we're going to talk just a little bit about overtraining and um, AI students and what, what what you're going to need to do basically for your homework. So we noticed at the end of the last video we had trained on 60,000 cases, which is not a trivial number of examples, and we got 91% accuracy. Now, every time you run this program, this notebook, you'll get a different number here. So, when this notebook was written, it was about 89% instead of 91%. So, there are a couple of reasons for that, one of which is that the weights start out. When the whole thing starts training, it starts with random numbers in all of those 100 and some thousand weights and biases, remember? Okay, so there's 100,480 weights and biases in there, and they each started out as a random number. So they all get nudged in the way that you're familiar with from your homework, except you were doing it with, two weights instead of 100,000 weights. And then you get your errors, you get your nudging, you get your errors, you get your nudging, okay? And it's not necessarily all going to converge the same way every time. It probably will be different. So we got 91%. But that is 60,000 images. There's 6,000 images in each category, roughly speaking, right? And then when we gave it the test data, this was 88%. So 3% of difference. And 3% of 10,000 is what? 300, right? So it's doing, it's only 3% worse, but it's kind of a little, wait a second. With that much data, why should it be worse at all? Okay, the test images were just taken from the same data set. Okay, these are big numbers. So what's going on here? And to understand what's going on, we're going to go back to our picture of a neural network over here. And we're going to imagine, okay, that this particular neuron, which gets its input from all 784 inputs, okay, it's entirely possible that you could have one neuron which memorizes, in some sense, this image. All 784 numbers went into each neuron, right? So in order to get a higher level of accuracy, one way that might happen is that essentially a couple of images which are very similar, or even one image, the weights get trained, okay, that one particular pattern over here is memorized by one neuron. So with this 128 neurons in the middle, it may be that, it kind of memorized some cases. And remember that this one neuron then gets output to all 10 of the outputs, so it's informing, okay. So it might just be able to pick which of the output neurons it likes, okay. As a practical matter, in a well-trained neural network, what's happening is that different parts of the hidden layer are memorizing different pieces of the input. So if we were going back to the digits, okay, then there's part of the input which is going to be like the bottom arc over here. And this bottom arc might be part of a 6, or it might be part of a 3, might be part of a 0, okay? So, and you know, the bottom arc could be in a couple of different places. So we might have, we might have one of these neurons which looks at all 10784 and it's recognizing a little bit of that bottom arc, and then it recognizes that little bit of the bottom arc and it sends a high signal over to these different output layers, and the output layer for the bottom arc for the 0 and the 3 and the 8, okay, are all looking for that bit of bottom arc. So in a good case, our hidden layers, the neurons are each recognizing some little feature of the input, which is generally useful in constructing an output. But something which has happened here is that in some ways our network seems to have memorized some cases. Okay, it seems to have, it's doing, there's about 300, there's a few hundred cases that it's just memorized and it's doing better on. And that's why on the test data it's memorized some cases that just didn't generalize. So the question is, what could we do about that? And that's going to be basically your homework, all right? So you'll get the same issue with the digits. And I'm asking you to do the homework with the digit data set. And there's a couple of different answers. One of them you could try, which I'm going to suggest that you all, I already told you, is you're going to try not normalizing the data and see if that fixes it, okay? In some sense, if all the numbers are bigger, then that should emphasize the differences or something, especially when you get to that final layer where everything is all going between 0 and 1. You have bigger numbers coming in, it might do something different. So over here, where was this? The normalization, okay? So this was the training. Here's the normalization right here, okay? I'm going to suggest you don't do that and see if that helps with the accuracy and with the memorization. What else could we do? Well, another thing we could do would be just to change the number of hidden neurons. If you increase the number of hidden neurons, does that somehow increasing the number of hidden neurons ought to turn it into something that's smarter? All right? If we have enough hidden neurons, we should be able to learn more. So does increasing the number of hidden neurons in this case make a smarter neural network, which then does better on the testing data? Or does it cause it to just memorize some more cases and it does better on the training but not on the testing? Does it use those extra hidden neurons to become smarter? Or does it use it to kind of cheat by memorizing some of the answers in the test data? That's for you to find out as part of your homework. And the other thing is going to be this thing over here where it talks about dropout. And dropout is going to randomly drop out some of the connections. So between the hidden layer and the output layer, we're going to cancel randomly some of those lines. And that's going to make it a whole lot harder to memorize. But on the other hand, it might make it harder to learn right. So you see this dropout a lot in real neural networks, but what does it, does it actually do what we want? It's for you to find out. Okay, so you're going to try and run these things with and without dropout. All right, so that's going to be part of your homework at the, for the end that's due on Friday. That's all, and thank you, and I hope this week turns into a good experience because you get to play with an actual network or with an actual task.